Cool.
Leighton's doing the gate ticketing.
Yeah.
I'm taking Leighton's.
Okay.
And I got donuts.
Excuse me. All right. The 5 people that stayed here yesterday had this for homework. I'm going to quickly go through it so everybody can see it. You all should have this already. You were here yesterday. If you weren't here yesterday, you don't have the new notes. You should come and get them. Anybody? Yeah, the notes on trigonometry. I handed them out before everybody left yesterday, so everybody should have them. All right. You also should have watched the video. I noticed it had something like 19 views. There's 30 kids in the class. 5 of them stayed here. 19 views. 1 of them was me, so 18 views. There should have been 25 views. So 7 people didn't bother to watch the video. That's okay. I don't care. Or you were together with somebody else and you guys got out some popcorn and watched the video like Netflix. Oh, this is awesome. No, that didn't happen. But again, I don't care if you don't watch it. All right. So yesterday, whole long lesson as to how this works, why it works, how to use your calculators. If you didn't watch the video yet, you're going to be very confused today. So, guess that'll be a lesson to watch the video next time. Here's what you do with all trig questions. Those of you who are here already have this done because that was your homework. You write down theta, which is any angle with which you are going to deal. I see that I have a 30 here. That is the angle I am going to deal with. So that is my theta. Then I write down everything else I know. I know that 24 is adjacent to my theta. I write adjacent. And I see that x is opposite to my theta. So I now know that I can do the tan of 30 will equal opposite x over adjacent, 24. Now we've already done a unit on algebra. How will you isolate x? If this was 10 equals x over 24, you would do 24 times 10, right? So, since math is always the same, you do 24 on both sides. Now, tan 30, if you didn't watch the video, you don't know how to find that. It's in your calculator. In your calculator, you will push, some of you will push 24 times tan button 30 equals. Some of you will need to push 30 tan times 24 equals. You could also push 24 times 30 tan equals. And all of that will give you the right answer. If your calculator looks like mine, and you push the button that says tan, and it writes the word tan on your screen, then you do this way, method 1. If your calculator doesn't write the word tan on the screen, then you have to do one of these methods 2. Now, all of you will do that with your calculator because there's one other thing your calculator can do to mess with your head. I am going to do mine. 24 tan 30, close brackets, equals. If you don't get 13.8564, your calculator is in the wrong mode, and I will fix that for you in a minute. Everybody make sure you can make your calculator show 13.856, pushing these buttons. Is there anybody that cannot? What do you get? Okay, bring me your machine. You get that too, Jadwinder? Okay, I'll fix yours in a sec. So for you, come here. All you got to do is hit this button.
Okay.
That switches it.
Okay.
Okay? Chad Winder, what does yours say? Negative 153. Chad Winder, look on the screen. What kind of calculator do you have? Hold it up so I can see it. Okay, look on the screen. Somewhere on the screen you should see the word D-E-G or the letter D. Do you see that? Or does yours have R-A-D and an R? Or G-R-A-D and a G? It's got an R? Okay, now look on your calculator for a button that has D-R-G. Push that button till a D is showing. And then try the same thing. You get 13.85? Done. Anybody else? Good. Now I know that X equals what? What does X equal now? 13.86. So I'm going to put that right here in red. 13.86. Now I want to find Y, correct? How do I find the hypotenuse of a right angle triangle? Pythagoras. Now, my calculator already has this number, doesn't it? So all I got to do is go squared, takes the last number and squares it, and add what? 24 squared to get an answer. And then what do I do with that answer? Square root. So you got to use your calculator and figure out how to do it. Square root 768. And my answer is 27.71. Can everybody do this, including the 5 people that didn't bother to watch the video? Yes? All right. So I will now tell you the answers to the bottom 3. Actually, I lie. I won't tell you the answers. I'm just going to write down the work that you should have done. Then you can use your own calculator to figure out the answer so you get the practice. Okay? So, theta was what? X, because you don't have an angle. Opposite was 35. Adjacent was 50. So, tan of X equals 35 over 50. Tan. Now, I don't have an angle, do I? Look on your calculator. Just on the calculator, not the button. Look at the tan button on the actual calculator. What's written right above it? Tan minus 1, right? Tan minus 1. What does negative 1 mean? What does negative mean in math? That's one thing it means. Opposite. If tan is what I push when I know the angle, wouldn't I want to do the opposite when I don't know the angle? Yeah. Yes. So when I don't know the angle, I need to push shift tan or second tan or INV tan. It's one of those buttons. You should all see it. So your calculator, depending on if you have a forward or a backward one, if it's a forward one, you're going to go shift tan bracket 35 divided by 50. Close brackets equals. If it's a backwards calculator, you're going to go bracket 35 divided by 50. Close brackets. Shift tan. And you may or may not have to hit equals. Everybody understand? Everybody try and do that now and make sure you get the right answer. The right answer is shift tan 35 divided by 50, close brackets, equals 34.99 degrees. We don't measure degrees in decimal places. Degrees have their own special way of measuring. You won't learn it till next year. So we're going to call that 35 degrees. Everybody able to do that? Going once? Going twice. It depends on your calculator. It either says shift or second or INV. Or it might be an S. Is it none of those things? Okay, it's second. Second tan. Then she's backwards. So you have to go bracket, just like I wrote right here, Hallie. Everybody good? Everybody good? Okay. What's the next one going to look like? Do I have a theta? What is it? 60. Opposite theta is what? X. Adjacent to theta is what? 7. So I'm going to use those three numbers to find x. Once I have x, what am I going to do to find y? Pythagoras. Got it? If you weren't here yesterday, you're going to do these two for homework. Everybody else already did them for homework. They're going to see the right answers tomorrow when I show them to everybody. Got it? After you find what x is, you do Pythagoras. Because then you know two sides of a right angle triangle. X, you're going to use those to find x. What about here? Do I have a theta? What is it? 80. What's 10 to that theta? Opposite is 10, adjacent is x. You're going to use that to find x. Does everybody get it? What is the only side of the triangle that we have not used trig for? The hypotenuse. We have done trig on both legs, haven't we? You guys aren't stupid. There's 3 legs to a triangle, yeah? 3 sides. 2 are legs, 1's hypotenuse. If there's trig for the legs, there's trig for the hypotenuse. That's what we're doing today. Everybody good? All right. Move it along. Go to your next page, which should say other trig ratios. Yep. Now, does it help you guys to see my calculator on the screen?
Yeah.
Okay, I'm going to leave that up there, but that means the notes have just gotten smaller. Everybody's okay with that? You got your notes in front of you anyway. All right. Tangent exists. Everybody please draw a triangle right here. Draw an A, a B, and a C. All capital. Now, if you were here on Tuesday, Wednesday, or you watch the video, you will know what letter I write here for this leg. What is it? Little a. What letter do I write here? Little b. What letter do I write here? Little c. Right? Okay. You already know in this blank spot here that tangent of theta compares the opposite to the adjacent. And those guys are the legs. Yes? Because you are not stupid, you recognize that there is indeed another side to the triangle. That side of the triangle is the hypotenuse. So I must have to do trig with the hypotenuse. The trig that goes with the hypotenuse is, one of them is sine. On your calculator, it is the sin button. The sine ratio, sine of theta, is the opposite over the hypotenuse. Now you guys, again, are intelligent young people. I've covered opposite and adjacent, opposite and hypotenuse. What's the only other combination? Hypotenuse and adjacent. That is cos theta equals adjacent over hypotenuse. Now, guys, that's only 3. There's actually 12 or so things, trig ratios. We are going to cover 3. Now, those 3 give us this pretend word, SOHCAHTOA. It's not a real word. It stands for sine, opposite, hypotenuse. Cos, adjacent, hypotenuse. Tan, opposite, adjacent. Now over here you should have some blank space, yes? Draw triangle ABC again. A, B, C. Correct? Put in the sides. Little a, little b, little c. Yes? Now, tell me over here, I want the sine of A, the cos of A, and the tan of A. There's A. Sine is opposite over hypotenuse, yes? What is opposite to big A? Little a. How do you remember what opposite is? It means across. Over the hypotenuse. What's the hypotenuse? Which is the hypotenuse here? Little c. What is the cos of A? Little b over little c. What is the tan of A? Little b. Now, I want the sine of B. So, where have I moved? I was here looking at my opposites and adjacents and my hypotenuses, yes? I am no longer there, am I? Where am I now? Up here. So now, I've moved. So my view of the triangle has changed, hasn't it? Right now, I am looking at Amy and Vicky. If I move, will I continue to be looking at Amy and Vicky? No. My perspective changes. My perspective changes here too. Now, what is opposite to me? B. So the sine of B is what? Little b over what? C. Because the hypotenuse never moves. Understand? So what then is the cos of big B?
Little a
over little c.
And the tan of B? B over A.
Oh yeah.
Please notice that the sines and the coses have just switched places. Makes sense, because I, the viewer of the triangle, have switched places, haven't I? Okay. Do you think anything else changes from what we did with tan? No, of course not, because this is a math class, right? And if something happens and works in math once, how often does it happen and work in math? Forever. Why? Because math is perfect. So let's look at this next question here. And tell me what I have. Do I have a theta? What is it? 12. Since I have 12, I know that this is the angle I am dealing with. So that is where my face is. So that is the corner from which I decide opposite and adjacent. Do you understand? Okay. So from that corner, what do I have? What about this triangle do I know? I know I have a hypotenuse of what? 25. And a what? Opposite of x. What uses O and H? Sine. So it must be sine theta equals O over H. Sine, what's theta? 12. What's O? X, what's H? 25. How do I solve that? Multiply, just like if it was regular algebra. Because sine 12 is just a number, isn't it? Just like pi is just a number. But we don't write 3.1415964, blah, 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 blah. We write pi, right? If I go to my calculator and I go sine 12, looks a lot like pi. It fills up the whole screen, doesn't it? Do you want to write 0.207911698 every time you need to write sine 12? Or do you want to write sine 12? I want to write sine 12. Why? Because I'm lazy. All math guys are. So this is just a number. Just like in algebra, I would multiply by 25 to get x alone, wouldn't I? So what do I multiply here? 25 sine 12 equals. My calculator is forward, so that's the order I punch it in. If your calculator is backwards, you reverse it. 12 sine times 25 equals. How many people have a backwards calculator? I know Blake does from yesterday. Hallie does. Evelyn does. Is that it? You too, Gripinder? Yeah, you do. Yours is backwards. Okay? I'm sorry. It's just the way it is. I personally grew up using a backwards calculator. I like the backwards calculator better because then it reminds you that you are taking the sine of angle 12. 12 sine. Right?
If you can backwards calculate, do 25 no.
You can do 25 times 12 sine, or you can do 12 sine times 25. Because sine is just a number. Like 2 times 5 is 10, or 5 times 2 is 10. Okay? So what's the answer there? 25 sine 12. Now see, my calculator is so smart, I don't even need to push times. Some of you might. It won't hurt you if you do. Close brackets equals 5.197. So that we are going to call x as 5.2. Everybody cool? Now, remember when we used pi and we left it as pi? And remember when we did radicals, and if we add the square root of 18, because 18 doesn't have a square root, we did 9 times 2, then we took out that and left it as 3 root 2. Remember that? Later on in math, you may find yourself leaving expressions like this as 25 sine 12, because it doesn't really exist, yeah? It filled up my whole calculator screen, right? So be aware of that. But for our purposes, we're going to always go to the decimals. Good? All right. Let's go to the next one. What do I have there? Do I have a theta? What is it? 19. Now, 19 means this is the angle from which I am viewing the triangle. I forgot to give myself hair last time. I don't have a lot left, so I shouldn't take it away from myself. If I am here, what do I have? I have a hypotenuse of x and adjacent of 40. What uses a and h? Cos. Cos theta equals a over h. What's theta? 19. What's a? 40 over x. Now, if you were here or watched the video, you already know the shortcut, right? When the number was on the bottom, we multiplied. What do we do now? Divide. This becomes 40 over cos 19 equals x. So on my calculator, 40 divided by cos 19. On a backwards calculator, 40 divided by 19 cos. Now, a bunch of you backwards calculated people are going to screw this up because as soon as you hit 19 coast, your calculator screen is going to fill up, isn't it? But that's not the right answer because you haven't hit what button? Equals. Equals gives you your answer. So I go to my calculator, 40 divided by cos 19, close brackets, equals 42.3. Now, this is the hypotenuse, correct? So it should be the longest side, correct? Is 42.3 longer than 40? So did I do it right? Most likely. A bunch of you are going to hand in to me your trig test, and you are going to tell me that the hypotenuse is shorter than 40. You laugh. How many trig tests do you think I've marked in my life? Not a billion. Because you guys don't even know how big the number billion really is. Let me give you a quick example. How many of you in this room feel that you are maybe 1 million seconds old? 1 million seconds. 1 million. How many of you feel you are 1 million seconds old? Put your hands up high. 1 million's a huge number. How many of you think you're that old? 1, 2, 3, 4, 5, 6, 7 of you. You know when you turned 1 million seconds? 11 days. How many of you feel that you are 1 billion seconds old? 1 billion seconds old.
We're in the building. No, we're not.
There is one person in this room that is 1 billion seconds old.
You.
Me. Because you know when you turn 1 billion? 37.
What?
11 days is 1 million seconds. 37 years is 1 billion seconds. So just to give you an idea, when people talk, when you guys get older and governments start talking about billions of dollars in debt, remember that example. And then listen to this example. The United States are $1 trillion in debt.
I don't think that's even possible.
That's like more than I don't think you can live that long.
No, you can't. That would be 37,000 years.
No way. No.
1 billion seconds would be 999 million.
No, 1 billion seconds is 1,000 millions. All right, back to math. Anyway, how many trig tests have I marked? Lots, not billions. And those trig tests, every year, straight A students get lost in the shuffle, and they're like, yeah, I got a trig opposite of J. SOHCAHTOA. Hiya! Here, Myers. And I'm like, oh yeah, I like this hypotenuse here that's 10 centimeters shorter than the other legs. Well. And guess what their answer is? My calculator said so. Which should be a meme. For math teachers everywhere. How many people would we have put on the moon if the people who did that said, my calculator said so?
1 billion.
We'd have nobody. Would we have heart transplants? My calculator said so. No. Would we have planes, helicopters, jets? No. Yes, Amshiman?
Technically, aren't we all really smart because we tell him what the calculator did actually do? It's just a computer. Technically.
I know that,
Yeah.
but if you people believe your calculator is doing the work, and it is the smart part of this equation. It's not. If your calculator was really smart, you could do this. Tell me what x is.
Whoa.
Hey, it didn't do anything. My calculator doesn't know nothing.
Dead.
It's just a
Mr. Myers.
Look, there's cameras over there.
Mr. Myers, how did you get the 40 over cos 19 again?
Okay, cos 19 equals adjacent over hypotenuse. My adjacent is 40. My hypotenuse is x. So now, if I had this, Sam, don't pay attention to the red. Pay no attention to the red. If I had 6 equal 12 over x, what would you do? No, you wouldn't. You would do algebra because you are going to pretend you don't know that 12 divided by 2 is 6. You would do either over 1 and cross multiply. 12 would equal 6x, and then you would divide by 6 and get x equals 2. Or you would do multiply both sides by x. X's cancel. 6x equals 12. Divide by 6, and x would equal 2. Now, in both cases, you ended up moving that 6 under the 12. So what did I do here? I moved the cos under there.
So
whenever there's a variable on the bottom, you swing that under there. I don't like teaching shortcuts that way, but we're running out of time. Bottom one, what do I have? Do I have a theta? No. What is it?
X.
Do I have an hypotenuse? 22. And I have an adjacent? 13. What uses A and H? Cos theta equals A over H. Well, I don't have a theta. Cos x equals A, oops, not A, dummy head. 13 over 22, right? So what do I got to use? I don't know my cos. So I must be doing the opposite of cos, which is shift cos. Shift cos of x equals 13 over 22. How do I do that on my calculator? Second cos 13 divided by 22. Close brackets equals.
53.77
Now, since it's a degree, do I leave it as 53.77?
No, it's 54.
54. Is everybody Gouda?
I still don't know what
Is everybody Gouda?
Yes.
All right. Now, next page. Please notice it says solving triangles. And there's only one on there, yes? That's the example. Solve a triangle. Solving means all sides
Oh my lord.
and all angles. Whales don't talk.
Mr. Myers,
What?
since the theta is 65, then E would be the...
One sec. A would be the bottom. Now listen. This confuses kids because there isn't a right order in which to do these questions. You guys get to a point in math, just show me how to do it. And I show you and you're like, I don't get it. Because you are not actually learning what you're doing, you're learning what to do. Do you understand the difference? Okay? All of you could build a house. Pick up the tool, cut the wood, build the house. Go. Would I live in that house?
Yeah.
No. I trust you people. Do you all know how to use a hammer?
Yes.
Can you all bang a nail into a piece of wood?
Yes.
Are you ready to build a house?
I have stick arm.
No.
I don't think I have
So, once again, I am going to show you a method to do this. You need to decide your method to do this. Do you understand?
Okay.
Nothing changes at the beginning, though. Do I have a theta?
Yes.
What is it? 65. Do I have, what else?
You have
The hypotenuse. No, you have adjacent.
I have an adjacent, which is? I need a hypotenuse, which is what? X. Okay, I'm going to put an X there. What else do I need?
The base, so the B leg thing.
Yeah, you all got this wrong anyway. Do I have an adjacent?
No, that's it. That's what's it called? The opposite.
There you go. Your opposite is what you have. Do you have an adjacent?
No.
So that's Y. Is everybody good? Now, you can only find unknowns if you have one unknown, right? Okay. So what in our trigonometry toolbox do we have? We have sine, cosine, tan. What in this question do we have? We have an O and a theta. So what are we able to use? Can we use tan? Yes, because it's O and A. Can we use cos? No. Can I use sine? Does it matter which one I use? No. So see where the problem is? Because you have a choice right now, half of you are going to choose one ratio, the other half of you are going to choose the other ratio, and then I'm going to choose whatever one I would do. The problem is, the half of you that chose something different from me are going to say, oh, I'm doing it wrong. I'm stupid. It doesn't. But when you're taking notes like this, you're going to follow me rather than do it yourself. Do you understand what I'm saying? And there's no right or wrong way to do this. I, personally, am going to use tan because we used tan yesterday, and a bunch of people missed it. So I'm going to do tan so I get extra practice with tan. But could I use sine? Yes. So I'm going to go ahead and I'm going to do tan. Tan of theta equals O over A. Tan of 65 equals 41 over Y in this case, correct? Y is on the bottom, so it's 41 over tan 65 equals Y. Let's find out what Y is. 41 divided by tan 65. Has everybody punched that into their machine somehow? I'm about to hit enter. 19.12. Right? Now, am I doing more work with this triangle? Yeah, so should I leave that on my screen? Yeah, because I'm going to use it again. But on my paper, I'm going to go ahead and write 19.12. Just in case I lose it off my calculator. Right? So now I'm going to change colors. So now I know Y is no longer Y. What is it? 19.2. So now can I do cos? Sure I can. I've got an A. Right? So cos would find me hypotenuse, wouldn't it? What else would find me hypotenuse? I know 41 and I know this side. Could I Pythagoras for it? Yep. Could I sine for it? Sure. Is there a right or wrong way to do it? No. So is it difficult for me to teach to you? No. I can give you the tools and you got to make your decision. Equals. Yep. Everybody good? Now, since this is a trig unit, do you think I'm going to use hypotenuse or Pythagoras? It's a trig unit. Do I want to do as much trig as possible? Yeah, because I'm the trig teacher. You are welcome to use Pythagoras, but I'm going to use sine. So, I come over here. Sine theta equals O over H. Sine of 65 equals 41 over h. H is x. X equals 41 over sine 65. What's x equal? .24. So I'm going to go ahead and write that in here. 45.24. Have I solved my triangle? Look closely.
No.
What is missing?
The angle.
The last angle. How many degrees are in a triangle?
180.
180. How much is this? 90. How much is this?
65. Oh,
What's left?
you can add them together and subtract 180.
90 minus 65.
90 minus 65.
Yeah.
90 plus.
Oh, so now you need 90.
90 minus 65, Amshiman. If this is 90, then 90 of my 180 is taken up, right? So these two have to add up to 90, don't they?
Oh. Good point. Never mind.
Will your way work?
Yeah.
Of course it will. But you can save yourself a step by just doing 90 minus what you got, right? C equals 90 minus theta. 90 minus 65, C equals 25 degrees. Am I solved? Yes. Now, I am going to do something a little bit crazy down here.
Oh, yes.
Okay? Everybody draw this with me. It will look like a mountain. Everybody draw that. Got it? Got it? Okay. Now from the here, go straight out and up there and make that 90. Everybody cool? 35 degrees. 42. And 7. Find x. Yep. Ooh. And y. That angle right there. Yep. Talk to your neighbor. Work it yourself. I don't care. Listen to me, please. That and the next worksheet is your work for the rest of the period. That and that the next worksheet in your notes book. And that will take us to the end of the day.
Something I already.
We don't know what the GC is though. Because the 42 is not.
So what would we write for you?
Jack, I spilled some stir fry on your test. Sorry, buddy. Could I make a mean joke right now? Can you handle it? Are you sure? It's pretty mean.